Okay. Okay, we're back on record. Okay, so here are 5 practice problems. I would highly recommend that you do them and ask me questions if you have any. So we're gonna address a question of media usage. Now you got to remember this book was written in 2004. I'm trying to think when smartphones became like ubiquitous, like everywhere. I mean, of course you guys wouldn't remember. You guys, smartphones have been like your whole life, right? Right? Well, or were they? Or did they come maybe when you were in elementary school-ish, maybe? Yeah. So elementary school, what year were you guys born? 2000 something? Early 2000? Yeah, okay. So this is a little bit pre-smartphone everywhere, right? But so we're going to learn, and this is what is, well, we're going to learn how to use sample results to estimate or infer population values. Because, you know, most of the time there's no way we can get a value for a population. Populations are too big. But we need to be able to go from samples to populations, just like, you know, here's a population, and from there we take a sample, and from there we get some statistics. And if we've done everything right, then we can infer a parameter. And we're going to learn kind of how to do that. So the thing we're going to analyze in our example is what proportion of all American teens have a television in their room. Now remember, again, this is back in 2000. How many of you guys have television in your room? How many have a television in your room? 0. 0 have a television in your room. Isn't that so interesting? In the other class, there were only 2 that had television in their room. But everybody has a computer, right? Everybody has a computer? Pretty much, yeah. And CD players, I mean, you guys don't even own CD players anymore, do you? Don't even own CD. Oh, you own a CD player, Juliana? Yeah. You have a phonograph too? Like a play vinyl? You do? Yeah. Maggie, you have a CD player? Yeah. Yeah. I like having a CD to pop in, you know, every once in a while, listen to the whole thing, you know. I mean, I guess I could find it on Spotify or YouTube, but then I might have to put up with commercials, and I don't want that, you know. All right. So how can we answer these questions without asking every single American teenager? We can do it. We're not even going to bother guessing here. No, we are going to do some guessing here. Okay. So I'm going to do some guessing. So I have a number line here. And the x-axis of my number line, actually the label of my number line, because number lines are only x-axis, is the population proportion of youths with televisions. Okay? American youth ages 8 to 18. And I want to know here, between what 2 values am I 80% confident that the proportion of American youth with television lands? And I would guess, you know, personally, somewhere between 30% and 70%. 70%. That'd be my guess. I'm 80% sure that somewhere between 30 and 70% of American teens have a television in their room. Does that make sense to everybody what I'm saying here? Okay, so the interval that I am in my very unscientific way, I am 80% confident is 0.3 to 0.7. That is the interval. Think about interval notation from pre-calculus, right? I mean, I guess I could write it 0.3, 0.7. I'm not sure if I'm allowed to do that, but I'll remember later on. Okay. Now, that's 80% confident. But now let's say I want to be more confident. I want to be more confident. So I'm going to ask this question. If I want to be more confident than 80%, is my interval going to get smaller, or is my interval going to get larger? Now think about it for a minute. I want to be more than 80%. I want to be 90% confident. Is my interval going to get smaller, or is it going to get larger? Let's take a vote. Let's take a vote. L for larger and S for smaller. How many people say my interval is going to get larger? 1, 2, 3, 4, 5, 6, 7. Alexis, you're kind of on the fence there, huh? Yeah, okay. So like I said, how many people say it's going to get smaller? Brooklyn is saying smaller. Okay, Brooklyn, you are outvoted, and you are also wrong. But that's okay. It's totally fine, right? And I'm gonna make it extreme. Okay. I'm going to do something very uncharacteristic in statistics. I am going to make an absolute statement, right? I am positive of this statement, okay? I am 100% sure that the interval that has the actual percentage of Americans with television is between 0 and 1. I am 100% sure of that. And you are too, right? Because I'm 100% sure that it's either nobody has a television, somewhere between nobody and everybody. I mean, that by definition, it has to be in that interval, right? And so Brooklyn, can you see that as a larger interval? And I have more confidence. In other words, I'm giving myself more wiggle room. That's one way of looking at it. I'm giving myself more wiggle room. Yeah, well, I mean, if I said that the interval was 0.48 to 0.52, I don't know, man. I mean, I don't have a lot of confidence in that. That's a very tiny target. The bigger my target, the more confidence I have. That's even a better way of putting it, right? If I have a really big target, I'm very confident. If I have a really tiny target, I'm not so confident that I can hit the bullseye there. If the bullseye is the side of a barn, yeah, I'm pretty confident I can hit it, right? But if the bullseye is one little, shingle in the side of the barn, I'm not so sure. All right, that was actually 3 very good. Are those analogies? Is that the right word? Are those analogies, or are those? They're not metaphors, right? I never know the difference between analogy and metaphor. Okay. All right. So here is our problem. The Kaiser Foundation did a survey in 2004, and they found they did a written questionnaires to a random sample of 2,032 youths in this age range, 8 to 18. And one of the questions they asked was whether they had a television in their room. 68% answered yes. Now, I asked the question in my last class. Do you see the picture over here? Is that a boy or a girl? What do you think? Just unmute. Tell me what you think. Boy or girl? What? Nobody's going to even venture a guess?
A boy.
You think it's a boy? Emma, why do you think it's a boy?
The arm looks a little veiny.
Oh, a little veiny. Oh, I think this little bump here on his elbow kind of gives it away, but I'm not 100% sure. Somebody else said broad shoulders, but then somebody else said, I think thought it was a girl because the hairstyle was kind of like an 80s girl. I don't know, what do I know about 80s girls' hairstyles? In the 80s, I wasn't looking at girls. I was only looking at one girl in the 80s. We were married in 76, just so you know, the girl I was looking at, was, yeah, okay, fine. And then I started looking at another girl in 1985. That was my daughter. Yeah, see, so. I'm not even going to tell you that that's a lie, okay? Right, but I'm not going to tell you that. Okay, fine. All right, so they told us the proportion. So here's the info here. What are the observational units in this study? What are our observational units? Wait. We're missing Sylvia. Sylvia disappear? Sylvia must have fell out. Okay. Abby, observational units.
Would it be the American youth from ages 8 to 18?
I think it would be. American youths 8 to 18. In this study, I just kind of want to be a little bit more precise here because we're not looking at all American youths. Our observational units are really only these 232. You follow me here? Everybody follow what I'm saying here? Yes? Okay, great. Okay. I want the variable, and I want you to tell me whether it's quantitative or categorical. Alexis, variable, categorical. What is it? Categorical, quantitative? What do we got going on here?
Is it if they have a TV in the room, which would be categorical?
And it would also be binary.
Yeah.
Right? Because you got a TV in your room and you don't have a TV in your room, right? So categorical, binary. Yes, no issue here. Good. Okay, now, the variable of interest is categorical and binary. The relevant parameter of the interest is a proportion, okay? We're looking at proportions. We're not looking at means, we're looking at proportions. We don't ever look at the two of them at the same time because a variable is either categorical or quantitative. Now, is 0.68 a parameter or is it a statistic? Brooklyn. You want to see the problem again?
Is that a statistic?
It is. And why do you say so?
Because it was like the number of people with a TV in the room.
You're very close. It's from a sample. It's not just because it's a number. I mean, if we conclude that the population has a 0.68 television in their room or not, that's a number, but that's a parameter. But we got that 0.68 from our sample. Okay, what symbol am I going to use, Brooklyn?
Is it p hat?
Mm-hmm. It is p hat. And Brooklyn, when we finally get around to turning this into a parameter of a population, what symbol are we going to use? Look at the same sheet that you were looking at.
What was your question again, though?
Yeah. We know we got this 0.68 is a statistic because we got it from a sample, right? So we go from population to sample to statistic to parameter. And we know that for the statistic, you told me we're using p hat, but when we turn it into a parameter, what symbol are we going to use over here?
Pi.
That's exactly right. That's our comparable statistic. P hat goes with pi. They both start with p hat and pi. Okay. Does this study allow us to determine the exact value of the parameter. And I'm just going to tell you right now, no, it doesn't, right? We're going to infer the value of the parameter, but the only way to really find the exact value of a parameter would be to ask everybody. And that's just impossible. Are we okay with that answer? Are we okay with that? Yes, okay. So, is the central limit theorem for a sample proportion valid in this context? If so, what does it predict for the shape, center, and spread of the sampling distribution of the sample proportion? Okay, so what test am I going to use to see whether the central limit theorem works? I'll take a volunteer. What test am I going to use? What do you that's right there on your papers right there. You can look it up. I don't object to that. Help you remember it. How do I test to see whether the central limit theorem is going to work? No volunteers? Do I have to volunteer somebody? I'm going to volunteer Imani. I'm volunteering you. What's the test I'm going to use?
Is it n is greater than or equal to 30?
No, but that's a good guess because but n greater than or equal to 30 is for quantitative variables. That is when we're doing that for the mean. But we're with categorical variables. We're doing it for proportions. So what's the other one on your sheet there? Do you have it?
I don't have
You
it
don't.
up.
Okay. All right. Who has it? Okay, Juliana, what is it?
It's greater or less than 10.
What's greater or less than 10?
The it looks like n.
But it's not. No. Well, close. Okay. N times pi has to be greater than 10, or n times 1 minus pi has to be greater than 10. Both those have to be true. You ever see it on your sheet where that is? Yes? Hello? But we have a problem. I have a really big problem. I don't know what pi is. I know what p hat is, but I don't know what pi is. What am I going to do? What I'm going to do is, since I don't know what pi is, I am going to use my sample statistic to construct an interval of values that I think contains the actual, though unknown, parameter. Okay, so I'm going to say that again. I'm going to say it, and then maybe we'll do something with it. I would normally draw my normal curve, and in the middle here, I would put pi. But the problem is, I don't know what pi is. So I'm going to use p hat. So I'm going to go n times p hat greater than 10, and n times 1 minus p hat greater than 10. And if that works, then I'm going to make myself a normal distribution. Now, watch carefully. We'll do this with some real numbers on the next class, but 1, 2, 3, 1, 2, 3. I'm going to calculate my standard deviation by going p hat times 1 minus p hat divided by n and taking the square root. Doesn't that look familiar to you? Does that look anything like pi times 1 minus pi divided by n and taking the square root? Yes? Look similar? Yes. This gives me a standard deviation. This gives me something that I'm going to call, well, for right now, we'll think of it as standard deviation. It's actually called the standard error. But when I do this, if here is my p hat, and this is 1, 2, -1, -2, -3, +3. If I do this with just my sample, okay, that's all I had was my sample, I am going to be 95% confident that the actual population parameter is going to lie between whatever number that is and whatever number that is. I'm going to be 95% confident that pi is going to be somewhere in this range here. And we will actually do that on Thursday. That sound okay? Yes? Now, Juliana, I'm giving you a job. Yeah, I'm giving you a job. On Thursday, I want you to remind me to record it so that I can put them together, part 1 and part 2, so that people will have this problem. That work for everybody? We're good? Okay, go. Have a nice day. We'll see you later.
Thank you.
You're welcome.
I actually had 2 really quick questions, Mr.
Yeah,
Chair.
give me 1 second, Brooklyn. I just need to stop.